Welcome to solverfy.
Hello, my name is Margaret, and today I'm going to be helping you with a problem from Chapter 8 of Chemistry, the Molecular Nature of Matter and Change, 7th edition. And it's problem number 27, and it's asking us to draw the partial or valence-level orbital diagrams and the condensed ground state electron configurations for several elements. So let's get started. Now, I think personally that it will be easier for you to draw the orbital diagrams after you've done the electron configurations. So we're going to start with the electron configurations. So we shall do the electron configurations first in black. So all right. Now, the condensed versions mean that we're going to take the most recent noble gas, put that in brackets, and then fill in the rest of the, write down the rest of the orbitals the same way we would in the full-blown or the full ground state electron configurations. So first thing we need to do is locate titanium on the periodic table, and it is in the third row in the D block. It's the second D block element in the third row. So if we go back, the most recent noble gas is argon. So we're going to start by putting argon in brackets, and then continue as if we were writing the regular electron configuration. So the next would be 4s2, and then 3d2. Okay. Now let's move on to chlorine. And chlorine is all the way back behind argon. So its most recent noble gas will have been neon. So we'll put neon in brackets. And then from there, it will be 3s2, and then 3p5. And then finally, vanadium is the, we go all the way back to where titanium originally was. Vanadium is the element after. So its electron configuration will look exactly like titanium's, because so its most recent noble gas is argon, and then 4s2, and then you just add an extra electron, so 3d, whoop, not 10, bit overzealous there, 3d3. All right, so now we have our electron configurations, and the reason I wanted us to do that is because it will help us fill in the orbitals, right? So now in the partial electron, in the partial or valence orbital diagrams, essentially what you want to do is really similar to what we like to do in the electron configuration. You want to go to the last noble gas, and then for the entire row of following orbitals, you'll write those out and then fill in the electrons that are in those orbitals. So looking at the titanium, okay, so the entire row after argon, okay, is the, that's not quite right. So we have the, and we'll do this in another color just for giggles, brighten it up. All right, so here we have the 4s orbital. Right, and then the next one We have the 3D. Then finally, we have the 4p. Right? Because titanium's in this row. And so we know that its valence electrons are going to be in that row, if that's its outermost shell. So from there, we take the electrons that we know are going to be in that row, and we just start filling the orbitals that we know are there, that we see in the electron configuration. So one up and one down. Okay. And we still have to go back from the original electron configurations, and we still have to follow those rules. So we put one up in this orbital, and we put one up in this orbital, because they're all going to fill an orbital first before they come back and pair off. So with that, let's go and move on to chlorine. So chlorine's the same way. It's going to be the entire row following neon. So, whoop. All right, so we have the 3s orbital. We have the 3p orbital. And again, following those rules, those pair. We fill up everybody first, and then we come back to pair off. This is that simple. Coming back to finish off vanadium. All right, we have 4s. Ooh. Isn't a space? There we go. 3D, and then finally 4p. We want to go all the way to 3D, so we have 4. That's not what would go there. Sorry. There we go. So we have these two electrons that pair. And then we put 3 electrons in there.